This video works with even and odd functions, identifying is the function even or odd, and where we go with that later is identifying some symmetry that happens with the graph. So this slide in the box gives us the definition. If the function is even, if you substitute a negative into the function, you get your original function back. If it is odd, you substitute the negative in the function, but you get the original function back with a negative in front. So I have a few examples for you in this slide. Example A, f of x equals x to the 6th minus 2x squared plus 3. How you test it is you replace every x in the function with a negative x, and then let's see what happens. So we say f of negative x equals, and now here's an x, so we're going to replace that with a negative x. Here's an x, we're going to replace that with a negative x. So what it looks like is negative x raised to the 6th minus 2, replace the x with a negative x, and that is squared, and then plus 3. Now we need to simplify that right side. Negative 6, or negative x raised to the 6th, is a positive x to the 6th. Because a negative times 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 a negative would turn that to a positive x to the 6th power. And we have minus 2, and now we need to work inside that parentheses. Negative x times negative x is a positive x squared, and then plus 3. Now let's look at this function when we evaluate it for negative x. Did we get our original function back? So if I erase this, I have the red function and my black function. Does this equal that? Yes. So we say from the rule up in this box, if I get my original function back after replacing a negative in to the function evaluating it, then it's considered an even function because f of negative x equals the function. Let's go down to example B. We do the same thing again. We're going to replace the original function, wherever there's an x, with a negative x. So in this case, there's just one x here. We're going to replace that with a negative x. So f of negative x equals negative x raised to the 3rd power, and then minus 5. And now we have negative x times negative x times negative x. We get negative x cubed, and then minus 5. So now let's first look at, from its original black function to the new green function, did we get the same function back? No. Did we get the original function back with a negative in front of it to make it odd? No. So we would say that this example is neither even nor odd. So it's neither. Example C, same test. F of negative x equals, replace this with a negative x, replace that with a negative x. So the first x replaces with a negative x, still raised to the 3rd power, minus, replace this x with a negative x. Now let's simplify it. Negative x times negative x times negative x is a negative x cubed. And then we have a negative x times a negative x is a positive x. Now what I'm going to do, be careful here, is I'm going to take out a negative 1. I'm factoring out a negative 1. So what I'm left with is now a positive x cubed and a negative x. I'm going to show you why that is the case. To test to see if it's even or odd, if we come back up here, in the blue, you have to get the original function back. In the green, we want the original function back with a negative in front of it. Let's see if we have that. So from the original function in the black to the new function, we have that piece, and then we have a negative in front. So this is a scenario where it's considered odd. It's an odd function because f of negative x equals negative f of x.